Hello, this is our Hack Ohio 2023 challenge for Honda. So just a quick little introduction for our slides. We're going to first discuss the challenge, then our idea for the challenge, our approach, and our execution. So the challenge we're addressing is interior navigation, and specifically at college campuses, this can be very difficult because of the lack of up-to-date information in a rapidly changing environment. So students may struggle with, finding a quiet area to study, finding enough seats to house a group, or, wasting time traveling to an area that's already full or, can't house anyone else. This is where our idea, spot traffic, comes in. We are going to create an application that allows students to see real-time data regarding where crowd size and how busy any particular location is on campus at a given time. The hardest part of this project is going to be actually capturing the necessary data to assess how busy areas may be. We decided to record unique MAC addresses and a building's network to assess how busy the entire building may be. But to figure out room to room, we decided to record unique Bluetooth devices into the shorter range. So the best way we thought to execute on that would be using Raspberry Pi strategically placed around a building. They would allow us to log both MAC and Bluetooth using Wireshark packet capture software. We then decided we could send all of that information to a central database where we could process it and then display it to clients. And now we're just going to show a quick demonstration of how this may be executed. So for our prototype UI, we wanted to create something simple and intuitive. So green being the most available, red being the least available. And we just want to make it easy to understand and pretty accessible given our time constraints. And if maps of an area are available, we could also extrapolate this onto maps. And the more Raspberry Pis we place in a location, we could actually narrow it down room to room and not just something like floor to floor. So due to time restraints and monetary restraints, we weren't able to build full scale where we place Raspberry Pis all over a certain building and capture MAC addresses. But we were able to successfully retrieve data via running Wireshark on one of our laptops. Using that data, we could convert it into a text file to be analyzed in Python. So some of our prototype limitations, majority of Windows computers lack the necessary chip hardware to sniff MAC addresses versus Linux and Mac systems are more able to. To compensate for this, we created dummy text files to simulate our data so we could practice running it on our Python scripts. And IP addresses could also be used, but are less reliable due to IP addresses changing more frequently. And one note we just want to add in, one of the possible issues we noted when building to scale is overlapping Pi information. So if two Pis can capture one person's data who's kind of in between them, that could lead to duplicate data. So in order to combat that, we could just record times and then compare them to the central database. After working on this project, we realized that the fundamental idea of what we're doing could not only assist students determining where to study or where it's popular on campus, but this could also be used to assist companies such as malls determining where popular stores are, what kind of consumer habits are going, where stores they go to, the travel patterns within a mall per se. And that's all. Thank you very much.